cloud. All right. Okay. So we have to work on this question, right? X square y plus z cube equals 3 over 2 xyz, and we have to find dz dx at 1 to 1. Right. So what I do here is this. Sometimes if I got an old timer like me as your instructor, okay, what I generally then do is this: make sure that this point really does live on this, right? So let's see. This is like, you don't have to do this, but if this happens, then you will save a lot of time. So if I substitute this, 1 square times 2 plus 1 cube equals 3 over 2 times 1 times 2 times 1. Did I do it right? So this is 2 plus 1 is 3, 3 over. So that means the point does live here, right? Okay. So as I said, this is optional, but it's good to do, right? And if you go into the formula sheet, you shall see something like this right here, right? So see this here?
Yeah.
Here, yeah, right. So here we have something like this, right? Okay, so we can make a function f x y z equals x square y plus z cubed minus 3 over 2 x y z. Okay, all right. Okay, so uh, what we are, so yeah, I'm happy that more people are joining us. And this is asking us for dz dx, right? So all I have to do is obtain my df dx. So and with a negative sign. So df dx is how much? Look at this. 2 x square y. Everybody, not x square. Sorry, I forgot my calculus 1. Right? Okay. So that is 2xy here. And this thing, the z cube, the derivative would be 0. And this would simply be, I have an x here, so negative 3 over 2 yz. So that's what the numerator would be, right? And the denominator is df dz. So if I look at that, so first of all, this doesn't have any z, so that the derivative would be 0. And then z cube, the derivative with respect to z is 3z square. And here I have a lone z, so this will be negative 3 over 2 xyz, right? Now, in order to calculate it at 1 to 1,
Professor,
yes, sir,
wouldn't the Z go away for X,
it
Y?
will go away. Yes, sir. Thank you. And here, if I was still going to get right answer, it was going to be luck because Z is a 1 here, right? But very good. Yeah, very smart catch. Okay, thank you. Okay, so when we just go for this here, this guy, what we will get is negative, then negative 2xy. So y is 2, x is 1, this is 2, so that will be simply 4, right? Minus 3 over 2yz. So y is 2, so 2 and 2 will cancel. So that will be negative 3, right? And z is a 1. I'm just substituting verbally here. Then 3z is square is what? 3, right? And then what do I get? Somebody tell me.
You'd have 0 at the bottom.
Yes, so this one does what?
It doesn't exist.
Doesn't exist.
Exist. But if we did not have a zero on the bottom, then that will be your answer, right? Am I clear?
Yeah. That makes
Yes, sir.
Uh-huh. Uh-huh. Somebody asked me a question?
Oh no, I was just saying, yeah, it was clear.
Okay, very good. So it's not that there will be no answer, but in this case, at this point, it doesn't have any answer. And we can just quickly do this. I mean, I will not spend more than 5 minutes on this, but just to see that what's going on here. Let me pull up Desmos and see what that says for that. Okay, so here 3D. I'm doing it just for sake of okay. So what was the equation? Let me get that on a separate screen so that I can see it. Okay, so we had x square y, right? No, not
sense.
like that. X square y plus z cubed, okay, equals 3 over 2, right? Let's just get rid of this xyz. So here is the plane, right? And now let's plot the point. Which point we had?
1, 2, 1.
1. And see where that point is. So why is that? Okay, good. Okay, does it show the point? So looks like the tangent. So in here, you can see, like, take a view in which you will find out that the tangent plane is not going to have any slope, all right? And or we can try doing it in a different way, but it does look like the situation is slightly strange there, okay? Everybody clear? So another way we can try this is to just a moment. Just go ahead and calculate it in a different manner. So I'm taking taking fxyz. Now this time I'm taking small fxyz, and that is as we had that we got this minus z cube minus 3 over 2 xyz, and we will get the tangent plane at 1 2 1. Okay, so what we are going to do here is let's calculate the gradient of f. So if we do that, what we will have is, first let's differentiate the f with respect to x. So that is going to be 2xy, then z cube, the derivative would be 0, minus 3 over 2 yz, okay, then comma, and then what we will have is that we will have, let's differentiate it with respect to y, so we get x square minus 3 over 2z, right? And I don't know why I wrote it here, but I did, so I did. Okay, and then we are going to do it with respect to z, so that will be 3z square, because here I have no z, so that will be 0, minus 3 over 2 xy, right? Okay, so what we got is that if we calculate it at 1 to 1, what will be the gradient of f at 1 to 1? Let's put it in. 2 times 2 is 4, then 4, and then minus 3 over 2 yz. Z is 1, y is 2, so that will be 4 minus 3. And when we go to the next part, we get 1, then negative 3 over 2 times 1 will be negative 1 half, and then we will have, oh, and this will answer the question, right? Because our tangent plane at this would be normal to 4 minus 3 is 1, negative 1 half 0, and passes through 1 to 1. So what that will be, 1 times x minus 1 minus 1 half times y minus this 2, and then this component is 0, so there is no z in there. So what do we get is x minus 1, and these two will become plus 1 together, so that will be negative 1 half y equals 0. So let's go ahead and plot this tangent plane here. So I brought this back and wrote an equation for x minus 1 half y. Let me erase all this part here because we don't need it anymore. Okay, all right. So what we get here is this. You can see the tangent plane is perpendicular to the xy plane. So z cannot be written as a function of x and y. And we cannot define z implicitly as a function of x and y in a neighborhood of this point. Okay,